Okay. Essential question today. So how does stretching, compressing, reflecting, since we didn't talk about any of that on Friday, affect the domain and range? We saw how the shifts do that on Friday. How did the other thing we didn't talk about yet? So with these functions, essentially what we're looking at here is y equals a over x minus h plus k, right? Using the a, the h, and the k that we've talked about so many times. Okay? And that when I think about the h versus the k, I always want to think about which one's in the function versus which one's outside or after the function. And we can see that the variable is in the denominator. So when I say that the h is in the function, it's in the denominator with the variable. That's how I can tell it apart from the k, which is after. So, and of course, h is always our liar. K we trust. And then a, we'll see that we won't have any. We won't see a lot of ones up here today. A will be our stretching, or compressing, or reflecting. That's where we'll see those numbers. So we see the 0.25 here, the -2, 3. Like those are where our A values will live. Will be up on top where we used to see the 1. So as we're looking at this function here, we want to describe the transformations. So I want to, okay, I got that 0.25 there. I've got this 6 here. I've got this 4 here. How do I talk about what that's going to do to the graph? So all the language and all that stuff's not going to be any different than it's ever been. So I see that 0.25, that's less than 1. So that's my vertical compression. And just always with those vertical compressions, vertical stretches, we always want to talk about by a factor of, since that's less than 1, it's 0.25. Okay. Next thing I see is that 6. H is a liar, so I know that's my shift left. And make sure you're using that verb, shift or move. Left 6 units. And the 4, that's our up and down. We trust K. So, and down 4. Okay, so let's look at number 2. This. Okay. So Samantha, what's one of the transformations we could talk about there? Reflect over the x-axis. Okay, so the negative will take care of a reflection over the x-axis, or you could say vertical reflection. Your choice there. Okay. Brian, what's another transformation you could talk about? Move to the right 4 units. Okay. Ooh. Slow down, Turbo. Move to the right 4 units. Alrighty, and what? Vertical stretch by a factor of 2. Why did you put a question mark on the end of that statement?
Because I think it just got thrown off by the whole vertical horizontal.
Yeah, there are horizontal stretches, there are horizontal compressions, there are horizontal reflections. We just never really talked about it. Yeah. So Yep, 2 is a stretch since 2 is bigger than 1. And the negative already had its job of flipping it. The 2 is separate. Caleb, what's last one? 8.
Oh,
Move up 8 units. Yep. All right. So there's writing descriptions of transformations. Really shouldn't be any different than anything we've done so many times. All right. What's up, Caleb?
so I see that we're flipping over the x-axis.
Hmm?
We talked about flipping over the y-axis.
The negative would have to be down here. Yeah, like with the x is where the like if there was like a 2 here, if there was a negative here, if there was like a 0.5 here, those would be your horizontal reflections, stretches, compressions. So
Are we going to be doing that?
it's more of like a pre-calc thing, or college algebra thing. So, all right. So asymptotes. All right. So vertical asymptote is all about what x can't be. What value of x would make the math go bad? -2. So x can't be -2, which means that our vertical asymptote is at -2. Asymptote describes the x part where it won't touch that line. So just looking at the denominator, figure out what the x value would make things go bad. That's your vertical asymptote. The horizontal asymptote always wants to be 0. Yeah. But we look for that shift, right? Take that horizontal line and push it up. We can push it down. So we see that shift down 5. So that's going to push that horizontal asymptote down to -5. So y equals -5. So make sure you write those as equations. X is vertical, y is horizontal, counterintuitive. Right? And then domain and range is all just about voiding those asymptotes. So our domain comes from the left forever. As it gets close to -2, it's like, oh no, I don't like that. So it starts to peel away or curve along next to it. And it hops over -2 and it's all happy again. This is the same function for both these questions. So same 2 functions. Just looking at that asymptote there gives me those 2 numbers there. Looking at the range, that's my y values. Look at that y line. I come from an arrow down forever, get really close to -5, but never touch -5. Hop over -5 and start going up again. And we use that symbol that's just a U for union, which again means or. So we can plug in numbers that are less than -2, or we can plug in numbers that are bigger than -2. Again, implying that we're not allowed to plug in -2. We'll get answers out that are less than -5. We'll get answers out that are bigger than -5. Again, implying you're not going to get -5 as an answer. So did that 3 stretch affect the domain and range at all? No. So short answer to the essential question is it won't. Okay, so all this stretching, compressing, reflecting will not change anything about the asymptotes or anything about the domain and range. So that's easy. Okay, but that asymptotes change because of the shifting, not because of the stretching or reflecting. Okay. So the way we graph, going back and comparing it to Friday will really be exactly the same. So those of you guys that work on Friday, just follow the same kind of process here and it's easy. So. I would always start by looking for those asymptotes. They really do kind of guide everything that happens here. Okay? And the way I start that process is I've asked myself this question is what x can't be. And where I look for that is right there. So I go from here to saying, well, what x value can't I use? So I should be able to look and say, well, x can't be -4, because if x was -4, the denominator would be 0. That should not be a negative 4. I don't know why I wrote that. X can't be 4, because then the denominator would be 0, and we're not allowed to divide by 0. So if x can't be 4, what that means is that x equals 4 is my vertical asymptote. So I take that x can't be and immediately turn it into an x is, and there's my line that the graph won't touch. Okay, so there's my vertical asymptote. And while I'm talking about 4, I'm going to go ahead and put that right there in the middle of my table and say, oh, that's not going to give me an answer. As you guys that are gone Friday will tell you why that is in a second. Right there, see the 4, so go over here, try the 4, go there, 4. Then we want to look at that number afterwards. So that's 3, so y equals 3. Have another asymptote. Since these are both off the axes, again, I expect you guys to draw them and label them. The whole point of the asymptotes is to be seen, so if you don't draw them, then they're kind of pointless. They're not there mathematically, they're there for our eyes. We talk about them because it helps our eyes understand what's going on. So we need to actually draw them. So why we put the 4 here in the middle of the table is because we are going to have a graph on the right side and we're going to have a graph on the left side of the asymptote. We need to pick those x values that are to the right and to the left of that number. So just go ahead and putting that 4 in the middle. We'll pick numbers to the right and left of it. And just like on Friday, I told you guys kind of that pattern that I use. There's nothing magical about that pattern. It's just something that I like to use. You certainly could do something different. And it's just really a recommendation about numbers that are helpful. Okay, so the only number we can't pick is 4. Okay, what I suggested that you guys do is go a half away. So 1/2 more than 4 is 4.5. 1 away, so 1 more than 4 is 5, and then 4 away, so 4 more than 4 is 8. So a half away, 1 away, 4 away. And then go same pattern in the other direction. So a half away, half below 4 is 3.5. 1 below 4 is 3. And then 4 below 4, which is 0. Half away, 1 away, 4 away. In both directions. Yep. Yeah, that has nothing to do with that. So what we're going to see, why I pick these numbers that are close to the asymptote, this is where all the curving happens. So we really want to make sure we understand what's happening with the curve. And then as we move further away, whether it's left or right, the graph gets pretty flat. So we can kind of just sketch it from there, but we want to just kind of have an idea of where it's headed. So these 2 points here are going to help us understand the curve, and this will just kind of give us an idea of where it's headed. So these 2 points here are to help us understand the curve, and this point out here is to help us just figure out where it's headed. So 2 that are really close to the curve, or the asymptote, and then 1 that's further away. So that's all I'm trying to do. 2 that are really close to the asymptote, and 1 that's further away. So the half, the 1, and the 4, nothing magical about them, just pattern that I like to use. That's all it is. It's really something I came up with, and you'll probably hear anybody else say that. So, okay. The rest is calculator stuff. We need to type that into the calculator. I showed you guys on Friday how to make that faster using some of the tricks of your calculator. But remember, so as I do -2 divided by, and if I'm going to plug in that 4.5 first, 4.5 minus 4 needs to go in parentheses. If you don't put that in parentheses, it will screw everything up. And then the +3 goes after that. So make sure you have a good calculator that has parentheses on it, or not the calculator that came with your phone, but something better than that. Okay. So -2 divided by parentheses 4.5 minus 4, close those parentheses, +3. You guys need a calculator up here. So if you're using this app, all you have to do is tap the numbers there on the left, brings it up, and you go and edit Change that to a 5. Make sure you're hitting the delete button, not the clear button. On any calculator, delete, not clear. Change it to a 5, and then change that to 8. So we do those calculations very quickly without having to type it, using editing. Using a TI-30, type in the first one, and then you hit up. That'll take you back to the last thing you typed. You can edit it instead of having to retype it. Using TI-80, whatever, type in your first one, and hit second enter. That'll bring up the last thing you typed, so you don't have to retype it over and over again. Just edit it. You guys need to get used to those little tricks of the calculator to help you do things faster. If you're not doing it right now, then you're just going to be slowing yourself down when it comes time for a quiz. You need to practice these little things, silly as it might seem. Otherwise, it takes too long later. I can go back and I can edit those for the other values I wanted. Change that 4.5 to a 3.5 really quickly. So I can do all those calculations really rapidly without having to retype and retype and retype. Anything about the x's I picked? Anything about how I got the y values before we go to plotting? Okay, 4.5, -1. So I plotted those 3 on the right side, and we move along that vertical asymptote. Pretty flat. Curve through those points as you head off to the right. Get close to that horizontal asymptote on the right side. It should be below it because of the reflection. It's the first time you guys have graphed one where it's below the asymptote on the right side. Plot the points on the left side. Flat against that horizontal asymptote, vertical asymptote, curve down through the points. Head off flat on the left side. Arrows on both ends. Where your graph shouldn't bell away from the asymptote, should definitely not cross that asymptote. Little glass walls that are keeping it in. So as you guys were out on Friday, we talked about the word discontinuous, how that graph has a break in it. I can't draw the whole thing without picking up my pencil. Draw that part, pick up my pencil, then I can draw the other part. That's a discontinuous graph. Has a discontinuity in it. Even though the domain and range are different than we've ever done, they really shouldn't be too bad because of this number that we keep seeing is here's this 4, here's this 4, here's this 4. That's the number that shows up in the domain is the number we're not allowed to use. So negative infinity to 4, union 4 to infinity. That's what we're seeing here. We go from the left side, get really close to 4, start shying away from it, jump to the other side of 4, there it is again, and it goes right forever. There's our domain. And the range, all about that 3 we saw here and here. So down forever, gets really close to 3. Won't touch 3 though. Jumps to the other side of 3. And goes up forever. What number can I plug in, or what numbers can I plug in? Everything but 4. What numbers will I get back out? Everything but 3. That means. We're just going to do one more today since we did so many on Friday. You guys should have a pretty good basis on this. Not too much is changing. You will notice, as far as like with the stretch, obviously the reflecting, we can see what it did. The graph was up here on Friday, and now it's down here. The graph was down here, and now it's up here. That's that reflection. The stretching, that 2. So all you really see from that, it's kind of hard to see, is that the distance here to here has changed. That's where it's been pulled away. This has been stretched away from the graph. Normally this point would be right here. So we've increased the distance from here to there. It's being stretched kind of diagonally. So stretching is really pretty difficult to see. We saw with the quadratics, it made the parabolas really skinny. The compressing made the parabolas really wide. The cube roots and the square roots, we saw the stretch pretty effectively. It's not very apparent with these graphs. So, let's just do one more. I want you guys to come up with your vertical asymptote and your horizontal asymptote, and then I want you to come up with these values right here, at least on your own. Make sure you can do that. If you can do that part, you really should be able to do the rest pretty easily. Because the rest is just calculator and plotting. So I'll give you a minute to do that. Don't let the easy ones trick you, right? There's no number there. With the x, that means x can't be 0, so our vertical asymptote is at 0. It always seems to throw people off. You get so used to seeing the numbers, and there's not a number there, you get all weirded out. Well, 0 is a number too. Plugging that in over and over again. 3. Four, 1, 1.25. -5, 2.75. Mm-hmm. Yeah. The graph should look kind of like that. Again, just the only thing you really see from that stretch, right? We have that 3 up there. That this distance here has been pulled out, so this would be a bigger distance there than normal. Would normally just come to right here. The compressions on these get really, really tight against those asymptotes. I really try to avoid assigning compressions for graphing just because the graphs are just kind of a pain to draw. So we saw a compression here in the description. So with that, but I really will try to avoid giving you guys a compression as an assignment problem to do, just because they're not easy to draw. I've complained about compressions before, so I'll bet. And of course, domain. So it goes from the left forever. It's really close to 0. Hops over 0. Goes right forever. Range starts from down forever. It's really close to -2. Hops over -2. Goes up forever. So make sure you have your asymptotes labeled. And make sure that these numbers here should always be in agreement. That 0, that 0, those zeros, they should always be the same. Shouldn't be a mystery. It's -2, and then there's -2s here, and on that -2 there, they should always be the same. Okay? Should always be in agreement. Those. Okay? So as soon as you see that, it should let you know those things pretty quickly.